Did you know that ice, despite looking solid, is actually one of the most slippery surfaces in nature? But why is ice so slippery, while other solid surfaces aren't as much? Have you ever wondered why walking on ice is so risky? Stay with me to discover what makes ice so treacherous under our feet. Ice is a fascinating phenomenon of nature. It can transform a simple sidewalk into a dangerous playground. Whether for skaters, drivers in winter, or simply pedestrians, understanding why ice is slippery can help us avoid accidents, but also to uncover interesting secrets about the physics behind this phenomenon. Ice is water in a solid state, but what makes it so special compared to other solids? To understand why ice is slippery, we must first understand what ice is. Ice is frozen water, meaning that water, when cooled below 0 degrees Celsius, turns into a solid. But, unlike other solids like metal or wood, ice has a unique characteristic. It has a thin layer of liquid on its surface, even when it's very cold. This thin film of water is due to a phenomenon called surface melting. Basically, the ice molecules located right at the surface are not as tightly bound as those inside. They remain in motion, almost as if they were still in a liquid state, even when the ice is well below freezing point. Now that we have an idea of what happens on the surface of ice, let's see how it affects slipperiness. The real question is, why does this thin film of water on the surface of ice make us slip so easily? The secret to slipping on ice lies in this layer of water, which acts as a natural lubricant. When you walk, skate, or drive on ice, this layer of water significantly reduces the friction between the surface of the ice and your foot or vehicle. Friction is what prevents us from slipping on rough surfaces, but on ice, this layer of water acts like a kind of slippery cushion, almost completely reducing this friction. As a result, it becomes very difficult to get a good grip, which causes slipping. Moreover, the higher the pressure on the ice, for example when you walk or skate, the larger this layer of water becomes. The pressure of your weight melts a thin layer of ice under your feet or skates, further increasing slipperiness. But why does ice become even more slippery when the temperature warms up a bit? Temperature plays a key role in how ice interacts with our weight and movements. When it's extremely cold, at temperatures well below 0 degrees Celsius, ice is actually less slippery than you might think. This may seem surprising, but at very low temperatures, the layer of water on the surface of the ice is thinner, making the ice slightly rougher. However, as the temperature gets closer to 0 degrees Celsius, this thin layer of water becomes thicker. The ice is then no longer completely solid, but covered with a thin film of liquid water. It is at this temperature that ice becomes the most dangerously slippery, because the water layer is sufficient to further reduce friction. For example, this is why ice rinks maintain their ice at a very specific temperature, usually around -5 to -6 degrees Celsius. At this temperature, the ice remains smooth and solid enough for skaters to glide quickly and smoothly. If the temperature drops below -7 degrees Celsius, the ice becomes too hard and brittle, making it less suitable for figure skating or speed skating. Conversely, if the temperature rises above -2 degrees Celsius, the ice becomes too soft and difficult to skate on because it begins to melt on the surface. This precise temperature control shows how complex and fascinating ice can be. But ice is not always the same depending on environmental conditions. Ice is not just an obstacle to walking or driving, it can also become an asset for certain activities. A classic example is curling, a popular Olympic sport. In this sport, players slide heavy granite stones across the ice, precisely using this low friction to reach a target. Curling takes advantage of the slipperiness of ice to achieve incredibly precise trajectories. Another example comes from the Inuit, who have used ice to their advantage for centuries. To facilitate transportation, they use dog sleds, exploiting the low friction of ice to move faster on frozen surfaces. And of course, we've all seen images of ice skaters performing elegant figures, thanks to that thin layer of water that makes ice so slippery. Figure skating and speed skating are possible thanks to this unique characteristic of ice that allows for smooth and fast gliding. But ice doesn't always behave in the same way. It varies depending on the environment and temperature. There are different types of ice, and each has different properties in terms of slipperiness. For example, the ice found in our freezers is often less slippery than the ice found on a frozen lake. Why? Because natural ice, especially ice that forms outdoors, often has a smoother surface because it melts slightly and refreezes, creating a layer of water on the surface. Road ice, called black ice, is another type of ice that is particularly dangerous. Black ice forms when rain falls on a frozen surface, creating a layer of transparent ice that is extremely slippery. This type of ice is responsible for many car accidents and falls because it is difficult to see and very treacherous. Finally, glacier ice, which is formed over thousands of years, can also be slippery, but it has a more complex texture. Its surface is often uneven, which can provide more grip for walking, but it remains dangerous because of the cracks and crevasses that can be hidden under the snow. Let's move on to the conclusion to summarize what we have learned about ice and its slipperiness. Ice, with its smooth and immobile appearance, may seem harmless, but in reality, it hides complex properties that make it sometimes unpredictable and dangerous. In short, the reason why ice is so slippery lies in this thin layer of water that forms on its surface. This phenomenon, called surface melting, reduces friction and allows ice to become a true, natural ice rink. But the slipperiness of ice also depends on the temperature, pressure, and even the type of ice you are walking or skating on. So, the next time you slip on ice, remember that there is a whole world of physics behind that moment of imbalance. And above all, be careful, because even if we understand why ice is slippery, that doesn't make it any less dangerous. Remember to be careful in winter, and always walk carefully on icy surfaces. What did you think of this exploration of the slipperiness of ice? Has it changed your perception of icy surfaces? Share your thoughts in the comments below, and let me know if you've ever had a memorable experience on ice. And don't forget to subscribe to discover other wonders of the world around us.